We're gonna do a quick. Well, I'm gonna work through the Unit 3 review here real quick. I'm gonna first teach you a little trick in Google Word or anything. If you hit Control F, well, hang on now. Control F. Let me maybe get out of this ink thing. There we go. You get this navigation, and you can search for things. So I'm just gonna type in the word review. If I can spell it. And you get a list of all the reviews. I'm going to jump right down here to the review A. So this is the one I'm going to work through, and then you all will work through this one, Unit Review 3B. If I haven't told you before, these review Bs, were the old exams that I administered back 20 years ago when we met in person. Okay, so this first question, it's a bit ambiguous, right? It says, which savings account is better? And all I give you is the interest rate. Well, we have a nice formula called the effective interest rate, and that is, now my pen isn't working, come on, that is, here we go, E equals 1 minus R divided by M to the N minus 1. I think it's plus, actually. So we can use this to compare our three compound interest rates. Remember what that effective interest rate tells us. It converts all of these to a simple interest rate, to an annual interest rate. So for a 1 year period, that's the same thing as a simple interest rate. So in other words, what we're going to do here is we're going to note that monthly is something that's compound 12 times per year. Daily would be 365 or 365.25. I think we'll use 365. And then secondly, ouch, how many seconds are there in a year? Well, there's 365 days in a year. There are 60 minutes. Let me try again. There's 24 hours in 1 day. There are 60 minutes in 1 hour, and there are 60 seconds in 1 day. So whatever this product is would be our secondly compounds. How many compounds would happen in a year if it was compounded per second? So we're just going to type all of these into Desmos, and we'll compare it right there. Well, this is an old one from before. Here we go. So I will type in my little formula. Let's see, in parentheses 1 plus my R. So the first one will be 0.0498 divided by 12. And then that thing raised to the 12th power here minus 1. That is the effective interest rate. So the compounded annually interest rate that would get us the same amount of money if it was compounded monthly. Okay, notice this trick. I'm just going to copy and paste this. Control C, Control V. Okay, I thought I was going to do that. Control V, it did not work. It's because I'm using function. Try again. Control C, Control V. There we go. And then I just have to change these two numbers. So I'm going to change, actually all I have to do is change the 8 to a 6, and this is compounded daily. So that would be 365 raised to the 365th power. Well, there we go, 365th power. Note this one's a little bit less than the previous one. And then let's do the last one, the secondly. Now watch how I do this secondly. Oh, by the way, that should be a percent symbol in there, not a $ symbol. That's a typo. So that's 90. And then secondly, I didn't actually bother to calculate that, but Desmos can handle if I just do multiplication in here. And then because I don't want to type that whole thing, I don't have a number pad on the computer I'm working on currently. I'll just do Control V up there, and there it is. So there's our three effective interest rates. Let's go ahead and multiply each one of these by 100, just in case we aren't comfortable doing that mental arithmetic of converting these into percents. So I'm not actually going to write this work down on my paper, because we've got it all here in Desmos. In fact, what we could do is we could do a screenshot. So I'm going to do insert and screenshot, screen clipping, and all I need is these things. So there's my work saved on here. Ooh, let's change the format in here so I can move it around a little better. We'll just put that there as work, and then now we're going to make our decision. Well, notice all three of these compound interest formulas have a higher interest than the simple interest rate. And anytime you're working with you're choosing an investment option, you're going to want to pick the compound interest rate for longer periods of time. If it's short, like within a year or two, the simple interest might get you more money. So in this case, our choice is going to be, we want to pick option A, the 4.98% compounded monthly is best because it has the highest effective interest rate. So it's approximately, let's say 5.10% annual interest. Now, there's another way we could solve these problems is we could pick an investment amount. So say invest $100 for each one of these, and we could put it in there for a 5-year period, a 10-year period, a 20-year period, and decide which one is best. But in this case, we know, just using the effective interest rate, that the option B will give us the most money in the long term. In the short term, investment A might be a little bit better. Watch out for that on your review B question. There's a question similar to this, but I give you a little more direction than what you got here. Okay, question 2. How much interest will you earn if you invest $6,000 in an account for 20 years that earns 3.24% interest compounded continuously? Well, this is a problem. We don't have an interest formula for compound interest like we do for simple interest. So what we'll do is calculate the future value. Now, since this is compounded continuously, we know it's the A equals PE to the RT, and we know that the P in this case is 6,000. The R converted to a decimal would be 0.0324, and the time period is 20 years. So I'll jump over here to Desmos. I'll just type that mess in. 6,000. I'm just hitting the E. Desmos knows exactly what that is, and then 0.0324 times. Notice Desmos automatically drops that out of the exponent when I try to do that multiplication. So I put parentheses up there, and then I hit the Shift 8, which is how my keyboard allows me to do multiplication. You could also open up the keypad and just hit the multiplication button, and we'll toss in our 20 there. And this is our future value. So I'm going to round that to 2 decimals since this is money. So if we want to calculate the interest, we just have to subtract the amount of money we put in. In other words, in any compound interest formula, the interest is equal to the future value minus the principal. So I just have to subtract 6,000 from this, and that's my interest. Be careful with this one on your review B. I do the same thing. I ask for the interest, not the future value. All right, well, let's move on. So, should you make a down payment of $2,000 when purchasing a $15,000 car with a 60-month loan at 7.35% interest? Oh boy. So, a super ambiguous question, right? You could just say yes right away and just say it's going to reduce the cost. But what I'm looking for is that you calculate the 2 monthly payments and compare the total cost at the end. So, just a quick reminder of that monthly payment formula. That's P times R divided by 12, all that divided by 1 minus 1 plus R over 12. And for car loans, we used negative N because our number of payments corresponded to the number of months the for the length of a loan. Recall for student loans, we often used -20 because they were 10-year loans, and for mortgages, we used -12T because mortgages are often given in a yearly format. Okay, so we're just going to plug all our stuff in. Let me identify the things we've been given. So our principal, in other words, the amount we're buying is $15,000 with no down payment. I'll call that subscript ND. Or our principal is $13,000 if we do make a down payment. I'm subtracting this $2,000 from the $15,000. So I'll put a subscript D here. And then for both of these, our number of payments is 60. That's the length of the loan. That happens to be 5 years, by the way. And our interest rate's a bit high, 0.0735. But that's all we need. So let's just type this in to Desmos. I'll start with the no down payment, 15,000 times 0.0735 divided by 12, and that mess divided by 1 minus 1 plus 0.0735 divided by 12 raised to the -60 power. Oops. Okay, so the monthly payment with no down payment ends up being $299.50 a month. All we have to do to get the cost with a down payment is change this to a 13, and now with the down payment, we're looking at $259.57 a month. So we're saving $40 a month, $39.43 a month. So that might be nice, but we had to front $2,000. The other thing we might want to do here is also compare the total cost. So let me copy this, Control-C, Control-V, and we'll make this 15,000. So to calculate the total cost is we take the monthly payments and we multiply by the number of payments, and that's how much we end up paying for this car. So with no down payment, we end up paying $17,970. With the $2,000 down payment, I'm going to multiply this by 60, but I also have to add in the $2,000 we initially paid. Wow, that is not good at all. Look at this. All we end up saving is what? Like a little under $2,200. So in my opinion, come on, here, let me type this down. 17,970.07 minus 17,574.06. Wow, we only saved $395.98. By the way, we could have calculated that a different way. We could have taken the $299.50 minus the $259.57, noted, hey, we're saving $39 a month, multiply that by 60, and we get 2,000. Let's see. Well, there seems to be an issue here with correctness. Nope. I forgot to subtract the $2,000 we initially paid. So there we get essentially the same amount. Now the reason they're slightly different, this is 80 cents and this is 98, is recall I rounded these two numbers, whereas the multiplication I did up here I didn't round. So based on all these data, I would say it's not worth paying that $2,000 up front. We're only saving roughly $400 over the 5-year period, and we could have had $2,000 still sitting in our bank account, and to me, an extra $40 in my budget a month might not be that significant. Now, that all depends on what your monthly budget is. If you're as tight as can be, and you can barely afford another $5 expenditure in your budget, then it wouldn't be worth it. Okay, let's do this next one. So you receive an unsubsidized loan for $23,000. Recall what unsubsidized means. This means you are required to pay the interest on that loan. So if you are in a school for 2 years and defer payments for 3 months after school, what is the total cost of your education? Okay, this is a very similar problem to what we just did in that we want to calculate the monthly payments that we're going to end up owing on this, and then use that to calculate the total cost. So we have to make some assumptions here. First off, let's assume we're not going to pay the interest while we're in school. So to calculate the interest that accrues while we're in school, we're going to take that 23,000, multiply it by the 0.435, and then multiply it by the time that we're in school. Well, we're in school for 2 years, and then we defer it for 3 months after that. Remember, in this I equals PRT formula, simple interest formula, we have to convert this to total years. And I'm doing a very simplified version of this. We could do what was done in ALEX, where we figured out the daily interest and then use a 30-month accrual or 30-month and make this figure out how much we would add in for those 3 months. But I'm just going to do like what percent of the year is 3 months and use that as our calculation. So 23,000 times 0.0435, and then I'm going to do this addition here, times 2 plus 3 divided by 12. There's the interest we owe. So this is going to end up being capitalized. Okay, so then I'll add to that the 23,000, and that becomes the P that we're going to calculate the monthly payment on. So P equals $25,251.13. All right, now I didn't say this was federal, and I probably should have. So let's go ahead and assume this is a federal loan, which means the time length on it would be 10 years. And that rate is still going to be the same, 0.0435. So we just have to plug that into the monthly formula. Well, I'm going to go ahead and copy my mortgage payment formula because it's the same one we're using here. Well, I'm going to get the right key. Oops, Control C, Control V. So this number here becomes the 25,251.13, and my interest is the 0.0435. I'm going to put those in both places. And then the time frame here is 120 payments. That's 10 years of 12-month payments. So $259.87. I'll just go ahead and write that down here. On our notes, this is approximately 259.87. Well, oops, not 87. Easy there, killer. It's 88 when we round it appropriately. But I'm not going to round it when I calculate the total cost, because I'm just going to take this formula and multiply it times the 120 payments we're going to make. And our total cost then is $31,185.21. So we could do a calculation on what would the total cost be. In fact, we could do that right now if we paid the interest while in school. So I'm going to change this to 23,000, and then I have to add back in that 2251.13 because we paid that in school, and there's our savings. Now, is that worth it? I don't know. Let's see, how much did we actually save? $31,185.21 minus that 3656.19. So there we saved $500.02, and that's over a 10-year period. And we had to cough up 2151.13 while in school. Now, we did that for 2 years and 3 months. We would be making those payments. So if I divide this by 2 plus 3 divided by 12, oh, hang on. Let's not do it that way. We want to know how many months. So there would be 27 months that we'd be paying that. So while in school, we'd have to each month be paying $83.38 in order to save $529 over a 10-year period. So if you think about how much are you going to save per month by doing that, you would divide this by 120, and you're saving $4.41 a month over that time. I don't know that that's worth it, especially if while in college, your students are often strapped for cash. All right, let's do this credit card calculation. This is a simplified version. We're going to do oh no, this is not. This is the average daily balance for this credit card. Now, this is a tedious problem. And I'm going to go ahead and do this in Excel because that is the simplest way to handle this. I think we're the easiest way to handle this average daily balance. So what we need is the date and the balance, and that's really it. Okay, so let me make this a little bit larger font, and let's go from here. So March 5th, the balance goes from, so first note that this is the month after March, or after February, right? So February we ended with this much unpaid. And then our first purchase on March 5th is this $1,221 and 0 cents. So we need to add that 211.14 to the 1221. So that's the balance on March 5th. And then on March 10th, so 5 days later, we add in, so I'm going to select a previous cell. This is why I'm using Excel. We add in another $68.66. If you were doing this by hand, you would want to make this table to help keep track of this. And then 1 day later, we make a big payment, a $633.66 payment, although it kind of looks like it was a refund, and this is flight or something. I don't know. Anyways, it's a payment. How do I know it's a payment? Because of that minus sign right there. So then the next month, we're going to add in another, or the next time, 59.63. And that was March 16. Now, actually, if you look at this, March 16 occurs, there's 1, 2, 3 things on the 16th. Oh, look at that. There's a March 13th. These are all out of order. Whew, that is terrible. So on March 16th, we added in the 59.63, the 200, and the 1.25. So that's the balance on March 16th. But actually, it's not, because what we need to do is do March 13th. So March 13th, we added in a $7.49 charge. Maybe we went to Starbucks and got ourselves some coffee. So I can fix this quite easily because all I have to do is change it to refer to B5 for the new total on March 16th. All right, so there we go, March 13th. And the next date would be March 18th. I don't know why these are all out of order. Shame on me for using this. So March 18th, we added in another $8.98. And then March 19th, we just had one more charge added in, and it's this one right here. It's the $32.40. And let's see, March 20th, we add in a bunch of stuff here. So we've got the $40, and then that $1.25, whatever that is. That merchant wasn't happy with us. They lost money on that. And the $44.65. And then finally, March 21st. Here we've got add in a 70 0.98. Oops, I forgot to put a plus sign. And then finally, now I should be saying finally the 23rd, our last charge of the month, we added in $1,000, big charge. Okay, so then we should note that March, which is the month we're in, has 31 days. So we could say the ending balance, March 31st, is that same thing. It's just this. I don't know if that helps us. Now, what we want to do here is type in the number of days that this occurs. And really, I need to put in a March 1st here because we're tracking the average daily balance. So the beginning balance for this credit card is this 211. So from the 1st to the 5th, that's a total of 4 days of it being at that balance. And then from the 5th to the 10th, that's 5 days. From the 10th to 11th is 1 day. The 11th to the 13th is 2 days. The 13th to the 16th is 3 days. Notice I'm subtracting this date from that date. So 18 minus 16 is 2. 19 minus 18 is 1. 20 minus 19 is 1. 21 minus 20 is 1 and 2. And this last one, if I do this subtraction, that would take us up to the 31st day. So if I did 31 minus 23, which is 8. Ooh, I got scared about that. 31 minus 23, which is 8. That leaves us on the 31st, but what happens is that doesn't include that 31st day. So to get to April 1st, we have to add 1 to this to make it 9 days. Let me demonstrate that here. I'm starting on the 23rd and I'm counting how many days does it remain at that balance. So 1, 2, 3, 4, 5, 6, 7, 8 days. Yeah, so I'm not sure what I was thinking there. And then February 1st, it becomes a new balance. Now let's double check that this adds up to 31 days. So I'm just going to do sum and add, and we're at 30 days. So yes, we have to include that 31st day there. Let me do that one more time. So we count from the 23rd to the 31st. I don't think I counted the 23rd. So 1, 2, 3, 4, 5, 6, 7, 8, 9 days. There we go. Now I've got it right. Now, if you recall when we did this in the book, what we do is we calculate the balance times the days. So we're going to get the product of all of this times this. And what this gives us is the dollars times days, which is like a ridiculous number that doesn't make any sense. But what we're then going to do is add those all up and divide by how many days there are in March, which happens to be 31, and this is our average daily balance. That number. And that's what the credit card company is going to charge that 2.5% on. So let's pop back over here. Our goal is to calculate the new balance in April. What we need to do is calculate 0.025 times this $1,399.75. So I can do that right here in Excel. We can just do equals this and then times 0.025, and that's our 2.5%. So the finance charge is $34.99. That's it, assuming we make our minimum payment. And it looks like we did, right? We had that March 11th, we made a payment. As long as that was on time, we're good. So what we then do with this $34 is we add it to the balance of March. So the final balance is the last charge, the balance for the last thing we did, plus that finance charge. So February 1st, the balance on our credit card will be $2368.82, and then it repeats. And now our average daily balance is going to be higher unless we make some significant payments on this and don't spend as much. And so then the fee we're going to be charged will end up going up. All right, one of the last questions. We're going to file some taxes. So this one is not too bad to do in Desmos. If someone had a taxable income of $32,456 using the 2018 tax income, how much would they owe? So notice that $32,456 lands, the highest tax bracket they're in is the 12%. So they're going to owe 10% on the first $9,525 they make, and they earn 12% on the next amount over that. Well, their maximum taxable salary was this $32,456. So we're going to take that and subtract this number to get how much money is within this tax bracket. So I'm just going to type that mess into Desmos, and that's the total taxes we owe. So I'm going to go ahead and do the 32,456 minus 9,525 right in there, and there's the taxes we owe. So $3,700.22. Now, I don't know if I did this in the videos, can't remember. We could calculate the effective tax rate by dividing this number by 32,456. So what we're figuring out is what percent of their income was taxes. So their effective tax rate is 11.41%, which should make sense. That's a percentage between 10 and 12%. Because some of their money they owed 10% of, another portion they owed 12%. It's a little bit less than the like a flat tax at 12%. Okay, here's our last question. So the question here is, which mortgage is better? All right, well, to determine which is better, we have to calculate the total cost. So that involves calculating the monthly payment. Notice our P here for a 0% down payment is $225. You might be doing this, you're definitely doing this in your project if you chose to buy a house, as opposed to financing a college degree. So I'm going to copy my monthly thing from before, and I'll modify this to $225,000. And that interest rate happens to be, not much lower than what we have in there. And the number of payments here is 12 times 15, because we're doing this for 15 years. So there's our monthly payment. I'll just write that down because that's worth noting. $1,688.08 a month. If you are purchasing a home, and you think that's a reasonable amount, don't forget you're going to have to add in the insurance. I think it's called MIP, to ensure that if you insure the bank if you default on the loan. You're also going to have to add in the taxes into that monthly payment if you use an escrow account, and then you should probably add in your homeowner's insurance. That can all get bundled into that mortgage payment, and then someone else manages it for you. It's kind of nice, but it also means this is probably going to be closer to $2,000. Well, this isn't the number we need to compare, although we may want to compare the monthly payments to decide which one's better. The other number we want is what's the total cost. So the total cost is just taking those monthly payments and multiplying them by the number of payments we have to make. That's 12 times 15. And just in case you're wanting to know how many times you're making that payments, it's 180 payments. So we're looking at $300,853.50. That's not too terrible. Remember some of the other ones were looking like double the cost of the home. We're only, $80,000 over the price of the home? A little under $80,000 extra over a 15-year period. Okay, so then this one, we are going to make a down payment. So check out this shortcut. Many of you may be calculating 20% of this and then subtracting that amount. If we just multiply this by 0.8, that's actually our the amount we're going to finance. Let's go ahead and get that number. So we're going to borrow 180,000. But it might be worth noting how much that down payment is as well, because we have to think about that when we're determining which mortgage is better. So we have to have in our as cash $45,000. You can't borrow that from somewhere else and use that as a down payment. Banks won't allow that. Okay, so then our time is 30 years, and our rate here is 4%. So let's calculate our monthly payment on that. I'm going to copy this one because it's closer to what we need. We're going to change this to 180,000 and drop the interest rate. Actually, usually when you get shorter length loans like this, they actually give you a lower interest rate, and the longer loans tend to be a little bit higher. So I probably should have flipped these percentages to be more accurate to what happens in real life, but whatever. And we'll change this to 30. So here's our monthly payment, except we need to borrow 180,000. So our monthly payment here is significantly less. It's like cut in half. And that should make sense because we're doubling the amount of time we're paying it, so we can pay half as much, roughly. Not quite. We didn't borrow the same amount of money. We borrowed a little bit less. Now, let's get our total cost. So the total cost now is, what, 30 times 12. So that's 360 payments we're going to make at that amount. And then we can't forget that we dropped 45,000 into the house at the beginning. So our total cost here is $354,365.11. That's wow, that's 51,000 more than that 15-year mortgage. So we spend quite a bit more, and it takes us a lot longer to actually own that house, because you don't really own the house until you've paid a significant portion. The bank owns it, and you're just essentially renting it from them. So which is better? I don't know. It depends on your financial situation. I would say this is definitely better if you can come up with $45,000 as a down payment. Excuse me. This one I think is better if you can afford that monthly payment of $1,600. You own the house sooner and you pay less. If you could make the down payment, check the difference on that. Let's see, where's my mouse? Here we go. So if I go back to my 2-1, I change this back to 15. I need to change this to 180. Look at this is the definite best case scenario. You end up paying $288,082.80. So you don't pay a whole lot, only what, 60,000 more on the house over the 15-year period. And then check out what your monthly payment is. It's $1,350.46. So if you could afford the 45,000 and your monthly budget can handle a 13,000, that's by far the best option. All right, y'all, that's it for this. Enjoy this review here. I don't know if I've told you all this yet, but when I write the final exam, I will be pulling questions, writing questions very similar to what you're seeing on these reviews or in the worksheets above. In the final exam, we'll cover probably like 75% of the questions will be from Unit 3 and 4, and 25% will be from Units 1 and 2. So like expect a relative difference type of calculation from Unit 1, maybe a repeat of what's up with apportionment or some dimensional analysis question, and then definitely some sort of modeling questions related to exponential or linear models. So I'll probably give you a data set and ask you a bunch of questions off of that, very similar to what you saw in the midterm. As always, don't hesitate to email me with questions. show up for office hours or request a time to meet. I'm happy to meet and would love to help you finish this class strong. We got about, 5 weeks left.